Good day, math learners! For this video, we will be talking on the test concerning proportion. So, let us consider performing tests involving a proportion from a population. This test involves knowing the percentage of the population who are in favor of a certain topic or idea. For example, an election campaigner wishes to know if a certain candidate has a big chance of winning. Then he will be concerned with the percentage of the population that is in favor of the candidate. The population proportion denoted as P. It is a parameter that deals with the percentage value associated with the population. The point estimate of the population proportion is the sample proportion, denoted by this symbol. The sample proportion can be solved by this formula. Sample proportion is equal to x over n, where x is the number of elements in the sample having the same characteristics and n is the sample size. The sampling distribution of proportion by the central limit theorem is approximately normal if the sample size is sufficiently large, that is, nt is greater than 5 and nq is greater than 5, where p is the population proportion, n is the sample size, and q is equal to 1 minus p. The formula for finding the test statistic to test the hypothesis about the population proportion is Z is equal to the sample proportion minus P over square root of population proportion times Q over the sample size, which is N. For example, number 1, a fast food chain claims that 85% of the burger fanatics prefer to eat in their place. To test this claim, a random sample of 90 burger customers are selected and asked what they prefer. If 76 out of 90 burger fanatics said they prefer to eat in the place, can we conclude that the proportion of burger fanatics who prefer to eat at the place is not equal to 85%? Use 0.05 level of significance. So for the solutions, our given values based on the situation, n or the sample size is equal to 90, x or the number of elements or the number of the sample is equal to 76, p or the population proportion is equal to 85% or 0.85, q is equal to 1 minus p is equal to 1 minus 0.85 because we substitute the value of p, which is 0.85, and the answer is 0.15. The sample population is equal to x over n, or substitute their values, which is 76 over 90, and it is approximately equal to 0.844. And the alpha or the level of significance is equal to 0.05. Since we identify all the given values based on the situation, so for the step 1, we have to state the null and alternative hypothesis. So our null hypothesis is P is equal to 0.85 because this is the percentage population of the burger fanatics that prefers to eat in their place. And the alternative hypothesis is P is not equal to 0.85. For step 2, choose or identify the level of significance, and it is equal to 0.05. For step 3, we have to compute the test statistic with this formula, and then substitute the given variables in the formula. We have z is equal to 0.844 minus 0.85 over square root of 0.85 times 0.15 over 90, and it is approximately equal to negative 0.16. So the test statistic is negative 0.16. For step 4, we have to determine the critical value. Looking at the alternative hypothesis, we know that this is a two-tailed test because we use this symbol for our alternative hypothesis. So we divide alpha by 2 and substitute the value of our alpha, which is 0.05 divided by 2, and it is equal to 0.025. Subtract the result from 0.5. 0.5 because this is the half of the area of the normal curve. So 0.5 minus 0.025, it is equal to 0.4750. Look for the area 0.4750 on the z-table and find its corresponding z-score. So we have to locate the 0.4750, which is here, and determine the z-score. So the z-score is equal to 1.96. Since this test is two-tailed, the critical value is positive and negative 1.96. Shade the region to the left of negative 1.96 and to the right of positive 1.96 in our normal curve to locate the rejection regions. For step 5, illustrate the curve. Locate the test statistic in the curve that we have solved in step 3. So this is our normal curve. The shaded parts are the rejection regions, which can be located at the left and the right tails. The non-rejection region, which is in between of the rejection regions. The critical value, which is equal to negative 1.96, that is in between of negative 1 and negative 2. Just estimate the location of this value. And we have also another critical value, which is equal to 1.96. That is in between of 1 and 2, and still just estimate the location of this value. The test statistics that we have computed earlier is equal to negative 0.16. That is in between of 0 and negative 1. So estimate the location of this value as well. For step 6, draw a conclusion. Since the computed test statistic falls within the non-rejection region, then we fail to reject the null hypothesis. Thus, there is no sufficient evidence to conclude that the percentage of burger fanatics who like to eat burgers in the fast food place is not equal to 85%. For example number 2, it is believed that in the coming election, 65% of the voters in the province of Cebu will vote for candidate A for governor. Suppose 713 out of the 1,150 randomly selected voters indicate that they would vote for candidate A. At 0.1 level of significance, find out whether the percentage of voters is not equal to 65%. So, here are the solutions. The given values based on the situation are n, or the sample size, is equal to 1,150. X, or the number of elements or the number of the sample, is equal to 713. P, or the population proportion, is equal to 65% or 0.65. Q is equal to 1 minus P, or substitute the value of P, which is 0.65. So we have 1 minus 0.65. The answer is equal to 0.35. The sample is equal to X over N, or substitute their values, which are 713 over 1,150. and the answer is equal to 0.62. And the alpha or the level of significance is equal to 0.1. For step 1, we have to state the null and alternative hypothesis. Our null hypothesis is P is equal to 0.65 because this is the percentage population of the voters in the province of Cebu that will vote for candidate A for governor. And the alternative hypothesis is P is not equal to 0.65. For step 2, choose or identify the level of significance, and it is equal to 0.1. For step 3, compute the test statistic, and this is the formula that we are going to use. Substitute the values of the variables in our formula, and it is equal to 0.62 minus 0.65 over square root of 0.65 times 0.35 over 1150, and it is approximately equal to negative 2.13. So the test statistic is negative 2.13. For step 4, determine the critical value. Looking at the alternative hypothesis, we know that this is a two-tailed test because we use this symbol which is not equal to for our alternative hypothesis. So we divide alpha by 2, and this is the solution. 0.10 divided by 2, and that is equal to 0.05. Subtract the result from 0.5. 0.5 because this is the half of the area of the normal curve. So the answer would be 0.4500 or 0.45. Look for the area 0.4500 on the Z table and find its corresponding Z-score. In the table, we cannot find 0.45 or 0.4500 there, so we have to consider the closest value or values of this 0.4500, and they are 0.4495 and 0.4505. If we get their Z-scores, we have 1.64 and 1.65 respectively. So we will get the average of the two Z-scores, and that is 1.64 plus 1.65 divided by 2, and it is equal to 1.645. Meaning to say that the corresponding Z-score in between of 1.64 and 1.65 is equal to 1.645. Since this test is two-tailed, the critical value is positive 1.645 and negative 1.645. Shade the region to the left of negative 1.645 and to the right of 1.645 to locate the rejection regions. For step 5, illustrate the curve. Locate the test statistic in the curve that we have solved in step 3. So this is our normal curve. So the shaded parts are the rejection regions, which can be located at the left and the right tails. This is the non-rejection region, which is in between of the rejection regions. The critical value, which is equal to negative 1.645, that is in between of negative 1 and negative 2. Just estimate the location of this value. And we have also another critical value, which is equal to 1.645. That is in between of 1 and 2. Just estimate the location of this value also. So the test statistics which we computed earlier is equal to negative 2.13. That is in between of negative 2 and negative 3. So estimate the location of this value. For step 6, draw a conclusion. Since the computed test statistic falls within the rejection region, then we reject the null hypothesis. Thus, there is a sufficient evidence to conclude that the percentage of voters who would vote for candidate A is not equal to 65%. Thank you for listening, math learners. I hope that you will answer all the activities that we have prepared for you. Keep safe and God bless always.